Okay, we are back live. I wonder why I'm a bit tired. Fighting Torch Compile all day. Couple hours more of fighting Torch Compile, I think. That's gonna be the plan. My favorite. Well, it's gotta get done one way or the other, so. Okay, so what is this? Unable to hit fast path. Sting. Let's try a couple other things. Unable to, because of pending uninvoked backwards. This seems screwy to me, no? The fuck is the point of having a grad function like this if it's still gonna store the buffers in the same spot, huh? I thought the entire point... the whole point is that we have to be able to compile this thing. So screwy. Pending uninvoked backwards. Nah. Bro, what is this shit? Like... What is this? Actually, what is this? Wait, grad function. Compute loss. Rollout. There's no compile on this. There's literally no compile. Oh, it's the model, dummy. Okay, so... Apparently this is the thing that breaks it, right? This still has gradients in it. This still has gradients in it. So I think that this is correct. I think I just had it screwy before. I think I was differentiating with respect to the wrong thing before. Alright. Sure. Let's try that then. Okay, that is something. And we get to improve from here. Cool. Let me get this blanket off. It's too hot. I think we can figure something out based on this, right? I think it's pretty likely we can figure something out based on this. Alright. My chat broken? I don't think so. Here we are. Nine seven. That's fine, cool. We're gonna get some flops. So you have the grad function, compile, and compute loss, the rollout, and then you compile the functional for it. This is good. That's faster? Well, that's no good. Interesting. Alright, so let's just do... Do like this, yeah? Variable pricing, man, it's per job. Low end is priority support at like 10K, but we you know, we can scope substantially larger jobs than that. That's aimed at companies though. I do it for free for universities. And I teach like open source contributors for free as well. Mm-hmm. Exactly. The main thing, honestly, that we get the main thing that most companies want is custom simulators, right? You know, they have a problem. Maybe they have some prototype or LM or whatever, and they can't get anything to work because stuff is super slow. We write sims that are 1000x faster than what's out there. We have training code that's actually fast enough to keep up, and all these tools. So companies pay to just have like a sim written in a way that's guaranteed to work. Oh my gosh. Okay, so it's way slow with no compile. How about this? Break. Okay. What about this? Firefly algorithm? What? What is that? Is that worse? CNN speedups would be nice. Love your work. Recently came across Puffer. Grinded RLib at work. I am sincerely sorry about that. That library has taken years off of many of our lives, my own included, during my PhD. I feel your pain. Gonna start deep dive into learning more from someone who's worked. Yeah, go take a look. Hang on, let me pause this. Yeah, so go take a quick look at oops. Easiest thing is I've got guides. On my X, if you just go to the articles tab here, this one's the one you're gonna want. Takes you through making a little custom env with Puffer. If you do RL professionally, then the first couple chunks of this will be pretty easy. And you can build single agent, multi-agent, whatever. Puffer doesn't have like a ton of different algorithms or stuff, but what we have is really good and it's really, really fast. It should just crush RLib out of the box. Oh yeah, then there's this fun project. I put this together for the community a couple days ago so people can submit puffers to the website. There we go. Huh. This is weird, right? There's nothing more to be gained by doing this compile, really? You know what we should do? We should compare to to LSTM core. There's no way that... And you're saying that that actually does something for a conf? Really? Color me suspicious. You think of a reason that M's act like it builds... Be found... Did you register it? Well... I did change the build stuff yesterday, Convert. That's weird, though. Import... I don't know. Would not be found. Well, go look and see if it actually put the file there, right? Like, if there's no binary there. Oh. Do you have PufferLib? Like, did you pip install that PufferLib? Is it trying to import from a different PufferLib? You probably just, like, did the rebuild, but didn't actually bind, like, the current PufferLib. Yeah, but did you pip install... Wait, rather than puffer tank. But if you have the source, did you pip install -e, the current repo? Because you might have some other PufferLib. Like, go look at the path of PufferLib and see if it's importing from site packages. And you put CNNs used in many areas. Yeah, we use CNNs all over the place. Okay. Yeah, go make sure, Convert. Oh yeah, that's another thing. I've done that before. If you name a file profile, you can mess up profiling internals, which is fun. This is giving 6.75 T-flop. Hmm. That's what I thought. Zero to join arc. Yeah, the separate nets thing has not really been conclusive. There was a big ablation that showed separate was better for like one very specific robotics thing. I've seen it happen before, but it seems kind of dumb to me. I didn't even realize this test was totally stupid. Big difference. Yeah, big difference. Damn. That's obnoxious. Just the snake net architecture from 2.0 was specifically designed because it's like the only fast CNN I could come up with. It's designed for 11 by 11. Should be easy enough to get it to work by 8 by 8. You have to do a little math. Okay, well this is the thing that I missed before, right? This is obnoxious because this says that the compiled LSTM cell is worse than this. They're both better than I'm getting now, though. Oh, and I guess we should do... Oh, this is good. The batch size is kind of good. think having a PhD is bare minimum. No. Not at all. I have people that are contributing to research in Puffer that have barely touched AI. The only thing you can't get away from is like putting in work. Take a look at my guide, right? I'm interested to see what you like. I don't know if you've done high perf sim before, but like RL with Puffer is a totally different field. And that's not me over exaggerating. Like, it honestly just does not feel like the same field. What is your channel about? Like PufferLib, I know RL. I feel like is beyond RL. So PufferLib is my HyperF RL library. The project is really more of a comprehensive effort to just fix a ton of different things wrong with the field. So it's not just like make RL fast. There's also core research, right? There's hyperparameter stuff that we optimize. There's UI and there's like visualization stuff I'm working on now. There's like high performance simulation and simulation techniques. And all of it goes into one very, very simple package. That's PufferLib in a nutshell. Get into the industry. We'll also know, right? Like, it depends, right? There are people you're going to talk to who aren't going to talk to you if you don't have the paper credentials, but those people are really stupid. Puffer's the way to get engineers to write code. Yeah. Yeah, Puffer is very eng heavy. Get started. Hair white and trying to... Yeah. And then the thing is, RLib is just never going to be fast, ever. The Ray backend is just wrong for NSIM. I don't know if you know how many steps per second you're training, but our x-axis on our graphs, right? Like, we do 100 million steps in 30 seconds, very commonly. Millions of steps per second training. Like, when RL is just 1,000 times faster, it doesn't feel like the same field. And we have algorithmic improvements to boot. Are they CPU what? Are they We have CPU M's that run millions of steps per second per core, and then the entire training, the entire training loop runs millions of steps per second on one GPU. You can get like 100,000 plus with small networks training on a CPU though, if you really want to do that for some reason. All these agents are running in your browser. This is not running server side. You think I want to serve all these agents? Runs in your browser. Type, ledger library. Your library remains so under the radar. It's not under the radar. It's the fastest growing library out there in RL. Look at this. This is the growth on the project. And my Twitter as well. I'm pretty sure I now have I'm pretty sure I have the largest like RL Twitter account as well. Given that I pretty much just post about RL. I pretty much just post RL. I don't think there are any accounts that are as like purely RL focused as mine that are this big. So it's definitely catching on. If you open the website on a Raspberry Pi, that's on you, okay? You're free to go optimize the neural nets, but Matplotlib, fun. Okay, so there's the uncompiled batch. That is a fair bit faster. So this is what we could potentially get with XLSTM. Yeah, just they're fun to watch, right? And the thing is, like, games are actually meaningful in research. It's like common criticism, oh, RL's just used for playing games. Like, the people who say this have about 3 brain cells shared between them. Because, like, the RL doesn't care if it's flying a drone or playing a game. The RL doesn't care if it's driving a car or playing a game. We use games because they're really easy to interpret when stuff goes wrong, so they're really good for research. And they're pretty diverse in the challenges that they pose. I should still be able to get this to be... Oh, that's the inference. Huh. Yeah. Yeah, we're not doing quantization stuff just so that we can run demos a little better. On your screen, what are you currently building or testing? This is currently like a mock-up of Puffer's training loop. It's got like a very similar architecture, and I'm basically just abusing torch compile until it spits out something that is at least passably performant. There's some really, really aggressive perf optimizations we need to make. Pretty much. Welcome, Kevin. The hell? Yeah, Neovim. Why compile so slow? I guess it's running 2 tests. You can also just grab the, it's literally in our Docker. So if you just do this, it's a GPU container, so you'd need a GPU for it. But if you just run this, it'll include the, I mean, I guess you could also pull it out of here. And there's the config file. That's it. It's not riced. 2 plugins and a color scheme. It's not like super tricked out. It's pretty vanilla. Weird. Compile take forever. Interesting. Something's deeply wrong. Are we allowed to write to models? Well, for what, Jess? If you have a general purpose model enhancement, maybe. It could be. I'm just listening to like random EDM shit to keep me awake. Okay, see, this is what I thought. This is weird as hell. Oh? Oh, you dummy. Wait, what? The heck did I just do? Oh, dummy. How did I do double quotes instead of triple like that? Christ, man, what the hell is this? Upgraded from pandas. Work doing. TensorFlow PyTorch. There's no way you can't find tutorials on PyTorch or TensorFlow. They're like the two largest libraries out there. There's about 1,000,000 tutorials on that. Literally on the home pages of both of them, I'm pretty sure as well. Fuck is this? Yo, which tensor, dummy? Like, usually I'm helpful to people, but like, come on. They literally have a learn tab. Look. I mean, PyTorch, they have like more learning material than just about anything else out there. Because DQN's a bad algorithm. Like, what do you expect? It's actually funny because, like, what we have now is substantially better than PPO. Well, that's something at least, right? Um, hang on. So here's the thing. The sample efficiency wild goose chase literally killed this field. Like, that's the entire reason that people got out of RL in the first place. So I'm basically, at this point, I'm sick of and tired of even hearing it. Nobody bothered to do any engineering at all. Nobody needs to care about sample efficiency. How many people in industry do you think care about sample efficiency when I say, hey, I can make your sim really fast and then solve it with RL? Zero. So if you just make the sims fast, you don't care about sample efficiency. You actually care about compute, right? You care about how much compute it takes to solve your problem. That's what actually costs money. And if you can make your sim faster, That's just as good as making the algorithm faster. And one of these two is actually relatively straightforward to do, and the other one is virtually impossible. And it's not in comparison to how humans learn. We have billions of years of evolution baked in. Do you know how we make our reward functions? For our simple m's, we use the first most obvious thing we think of. For more complicated m's, we take the first 5 most obvious things that we think of, and then we automatically tune the weights with our hyperparam tuning algorithm, because we can do that. Humans prove off-pol can work? What? No? Huh? That doesn't make any sense. Okay, compile forever, come on. Sleep at night. I got another 45 minutes of this. Maybe 30. I've been skipping out on too much of my stretching lately. I'm gonna get a good hour of stretching in tonight. Working on flexibility goals. Not as awesome as just like lifting heavy shit all day, but kind of important as it turns out. Plus I kind of want to do a little bit of accessory work as well. Yeah, I'll say I get like an extra 3 sets of triceps in as well. That'll be decent enough to have gotten. I got my 6 heavy sets in for the day. And did 3 sets of 5, 355 deadlifts, and then 3 sets of, I think I did 7, 6, and 7 pull-ups with a 45-pound plate. And decent enough for strength training. Torch compile's kind of insufferable. How long it takes. Samsung, what? Isotopic. What the heck are these comments? This is athletic. It's a non-alcoholic beer. The only one that doesn't suck. And Samsung, I don't know what a TRM is. If they have a processor or something. Here, $100 shitty Samsung phone. I got this as a temp because I broke my old one. Okay, this is what we're looking for. So, according to this, we should be able to hit like, say 15, 20 million steps per second training with smallish nets. So we should be able to throw together a really sweet demo with this. This chunk is relatively easy to do. I have... Oh, that thing. It's kind of ironic that it's like tangentially sort of similar to the first thing I ever did in research. I did this like recurrent highway hypernets thing. I didn't look at the details of it, but I don't know, it sort of reminded me of this. Minerals. Does steak have minerals? I ate a lot of that. Oh, that's also BF16 though. I want to start on this chunk today because I'm going to mess it up if I do. Let's just go add a couple things to this. Intelligence. Do everything a human can do. It would have to be as smart as a human is. So solving the field. Be a good description of the limitation. Okay, LMs are really stupid. Hey, Justin. Heh. Yeah. Is it 6? I see 8 on YouTube, 2 on Twitch, and I don't know how many on X. It was up to like, I think it was up to like 16 earlier today. Okay, so this gets autocast, right? Okay, there you go. That's autocast. That's when you have to get stuff triaged. Because, like, you can't answer all that. Yeah, and I'm gonna go to bed pretty soon as well. Well, not bed. I'm gonna go, do my stretching. Okay, this gives us B float, right? Okay, grads come back float 32. Batch goes in B float. Yeah, that's good. So you actually really don't lose much by doing B float here. Can analyze or describe games but can't play games? Yeah, they're stupid. And they're frickin' slow as well. Okay. So this should be good. This at least today we'll have gotten this perf test in. Teh. Yeah, it just, I don't know, man. It's better to just ignore the people who don't actually want to like learn things. Huh. Compile times still suck. It's like embarrassingly bad for Torch. I wonder if use I wonder if can we try like the trace JIT instead of compile? Is that easy to do for evaluate? It's kind of not, right? Can you JIT trace a model? Right. Can you torch.jit.trace It's so freaking unbearably slow. When I have dealing with stuff I'm completely unfamiliar with. And then the most common one is this. I have a really dumb model that's one-line autocomplete. Which, like, just makes you type fast. I like this one. Basically just removes typing speed from consideration. Fuck, this compile time is so bad. Oh, because you dummy. Why do I have train on like this? This is supposed to be gone. Okay, hang on. Try this. Awful. Like, literally unusable. That's better. Compiles quick enough. Okay, so this is what we get out of Torch at the end of the day, right? So we have 3.8, 3.4, and 29. So, like, high 20s. We have high 3s, high 20s, yeah? Okay, and then Jax gives us lower train, higher eval. out of the box. Oh wait, but this is now... Yeah, but this is with AutoCast, no? That's B float. I'm gonna just time B float perf. Okay, 4.4, 3.8. Okay. So Python ends up being, Torch ends up being a little bit better. And then this. -1 for Jax for killing my stream. For a second there. Substantially worse training. Not at all feeling the Jax magic. So even just with reduce overhead, we're already matching Jax. Interesting. Hmm. Several pots of coffee. I'm not gonna give you that information, but yeah, there's some people I would think of. Um, could I not just write the damn code the exact same way? Wait, what am I even missing? So basically this is, yeah, it's the same code. I'd have to write the optimizer this way, but other than that, it's fine. Mega pain in the ass. Really a mega pain in the ass. The thing that's obnoxious here is this needs to get duped over seeds, right? So guys, I guess let me tell you what's going through my head at the moment, right? Um, I've played around with a ton of different things here. Okay? And like we made some decent progress. So even with a version of stuff that compiles, here, let's just do it this way. So with a version that compiles like relatively fast, like this is like a relatively friendly, usable version. Yeah, so we get like quite a speed up here, you see? So presumably I'm going to be able to speed this up several fold over what Puffer is now, and this is also BF16. So like presumably I can get some good speed up. But this is still using a 20th of the GPU. Does Torch VMAP actually work? I'm trying to think basically like, do we want to queue multiple jobs on the same GPU at the same time? LM information RL based. I think Helix does, sort of, right? I don't know that area. Discord.gg/puffer. Link is also on puffer.ai. Right here. I have a feeling the Jax eager mode is super slow, right? Because Jax is just not meant for eager. I wonder if we can get optimal flops out of packing then. That's an interesting idea, right? Hmm. That's a weird one. I'm not sure. Hairless stream. I like my hair, thank you. 10 years? Depends how many stupid comments I have to answer on the internet. It's okay, I'll make sure that if I lose all my hair from this stream, I'm still jacked enough to pull the look off. Speaking of which, I gotta go, I gotta go do my stretching and call it a night. So, let me finish my thought here, though. What we have discovered from today. So, one, we are now absolutely certain that Jax is not magically faster than Torch. Okay? The thing that Jax is nice for is that you don't have to fight its compilation anywhere near as much. That's the only thing. You have to write all your code completely different, but you don't have to fight the thing so much. Which is kind of nice, kind of okay. I don't know. Torch is still the preferred library, I'd say. You can also get more out of Torch. Once you have compile, you can get more out of Torch with tuning, but the freaking compile settings for that take forever. The only other thing that remains to be seen here, so I want to investigate packing. Basically, maybe we should just look at jobs in terms of flops instead of wall clock, right? Because maybe we can essentially have multiple jobs on the same GPU for small nets, and we can just always get everything up to like near perfect flop util or whatever, and then we can count stuff in terms of flops, which would be super nice. TensorFlow just bad. TensorFlow just bad. So I think that's probably what we're going to investigate. If I have time to do tomorrow, that's what we will investigate. Because this number is not good or satisfying. Now, the thing that is good, okay? Like, this number implies that we should, with basic compilation, be able to get at least 10 milstep per second training. So we should be able to make Puffer 2 to 3 times faster than it is now, no problem. Which is kind of awesome. But then the thing is, this is like 1/5 of the speed that you can get out of your GPU. So, like, I want 100 million step per second training. And we should be able to get 100 million step per second training. I'm going to have to think about it, though. Now, I guess one thing we can do... I did figure out the functional thing that I figured out was the unlock that lets us compile pretty much whatever we like. So we can probably do Jack-style VMAPs with that. We'll see. And then that would, if we did that, it would make it really easy, essentially, to use multiple backends. I think that might be the way to go. Is that we have normal torch modules, you have the class interface, and then you just have the functional call on it. I think that's probably the way to go. We made some good progress either way today. We made some good progress. This shit's hard, you know? Like, when you have to deal with stuff like this, it's a pain in the ass. If you're interested in my work, just give the X a follow. Give the GitHub a star. Feed the Puffer. There's going to be more. I think we probably have a couple PRs to only fish, right? Oh, I have to do this as well. Oh, cool. So, yeah, here's a nice little PR to the Puffer. So we have another fish to merge in tomorrow as well, which will be funny. I gotta get some rest. Thanks, folks.